Hi, welcome back to the section. In this module 4, in that moment of inertia as well as the centroid, we come across the derivation of simple geometrical figures. Nothing but these are same as the numerical problems. If you know how to solve the numerical problems, then this will be easy. So, in this moment of inertia concept, we are going to derive moment of inertia of some standard geometrical figures. Which are the standard geometrical figures? Like square, rectangle, triangle, circle, semicircle or quadrant of a circle. Now, the procedure remains the same for all the derivations. Let us look into some of the standard geometrical figures. The first one is rectangle. So, let us consider a rectangular lamina. Lamina is nothing but plane. Let us consider a rectangular lamina of breadth b and depth d. Breadth is b and the total depth is d. Let us consider a small elemental strip here. So, okay. Then for the entire rectangle, the centroid will be somewhere here. Let us write the axis passing horizontally and vertically. We call that one as xx and yy axis. Now, the distance of this elemental strip from the xx axis is y. Then the area, the distance of this small elemental strip, we call that one as dy. Now, the area is given by the total area is breadth into depth, that is b into d. Elemental area, that is A, is given by b into, that is this width multiplied by this depth, b into dy. Understood? Next, we are going to calculate the moment of inertia. The moment of inertia of the elemental strip about the xx axis is given by, we know that moment of inertia is nothing but area multiplied by distance square. We are talking about element. The area of the element is given by b into dy. I will write it here. Okay. Area of the element is b into dy, write it, multiplied by distance square. From the element to the x axis, the distance is y, as we seen in the figure. So, it will become y square, area multiplied by distance square. Therefore, moment of inertia of the total area about the x axis is given by, what we need to do? We need to integrate this value with respect to some limits. So, let us integrate this value with respect to the limits. What is the limit? So, the limit is the total distance is, the total depth is d, this is the xx axis. So, let us consider this one as 0. So, from here to here distance will become d by 2, that is below that. So, it will become minus d by 2. From here to here distance is d by 2, that is above, it will become plus d by 2. So, the range in the vertical is from minus d by 2 to plus d by 2, this is 0. So, the limit will become minus d by 2 to plus d by 2, that is total is d only. Then integrate it with respect to y, integrate this one with respect to y, b is constant, take it outside. So, we know the integration of the common factors, that is integration of x power n is given by x power n plus 1 divided by n plus 1, that is y power 2 plus 1 divided by 2 plus 1, y cube by 3. So, the limit will come here. First apply the upper limit minus apply the lower limit. You are going to get Ia, the moment of inertia of the total with respect to xx axis, we call that one as Ix bar. From this calculation, we are going to get that one as Bd cube by 12. Similarly, you can get Iy bar is equal to Db cube by 12. This is regarding rectangle. Now, let us look into the another case, that is triangle. Now, let us consider a triangular lamina of base b and depth d are h as shown in the figure. Base is b and the depth or height is h or d, whatever it is. Let us take that one as d only. Okay. Now, consider a small elemental strip from the base up to the elemental strip, let the distance be y and the remaining distance will become d minus y, total height minus this height, d minus y. Let us the height of the elemental strip will be dy. Now, what is the base width here from here to here? Do we know that one? We do not know. So, we need to calculate that one by using the similar triangles. So, base by base is equal to depth by depth. So, let us call this base as B1. So, base by base B1 by B, B1 by B is equal to height by height. For this smaller triangle, the height is d minus y. For this bigger triangle, height is d. So, width by width is equal to height by height, depth by depth. So, cross multiply b1, you are going to get it as d minus y into b divided by d. Now, calculate the area, total as well as elemental area. The total area, it is half into base into height, half into width is b, height is h or d. So, let us take this one as d only. Then elemental area is given by, elemental area is how much? So, here we have, see the elemental strip looks like a rectangle, is it? This is the elemental area, it looks like rectangle. So, the rectangle area is given by width into depth, that is b into d. So, b is given by, b you already calculated, width is d minus y b into d. So, write it, into depth is dy as shown in the figure. Now, calculate the moment of inertia. Moment of inertia about the base, that is AB, moment of inertia about the base of the triangle, it is given by AB. We know that moment of inertia is nothing but area multiplied by distance square. So, the area of the element, it is moment of inertia of the element about base AB, that is given by area, that is we calculated, write it, multiplied by distance square, the distance is y, so y square. So, multiply this one with the inner terms, you are going to get this much. Then, once you get this one, here dd get cancel, here dd get cancel, then calculate moment of inertia of the total area with respect to the base AB. What we need to do? We need to integrate this value with respect to the limits. Limit is what? Here the base starts from 0 and the total height is d. So, the limit will be 0 to d, 0 to d. So, here there are two terms. So, integrate it separately and apply the limits from 0 to d. If we integrate and solve it, you are going to get that one as IAB is equal to BD cube by 12. IAB is equal to BD cube by 12. We took AB axis. Suppose if we took moment of inertia of the xx axis, so nothing but centroidal axis, then it is given by Ix bar minus A into y square, that is given by BD cube by 12 minus area is half into B into D multiplied by y, nothing but I will show you here how it is. It is the centroid. If the line, horizontal line passing through the centroid, that is xx, we call that one as centroidal axis. So, with respect to the centroid, we have the distance from the base to the centroid, the distance is how much? In the centroid we come to know that it is 1/3 of the height, 1/3 of h or 1/3 of d. So, it is 1/3 of d whole square. So, IAB you are going to get it as BD cube by 36. Similarly, IYY you are going to get it as we are writing it directly dB cube divided by 36. That is all. In this procedure we can derive the moment of inertia of some other geometrical figures. Thank you.